Welcome to a new episode of OpenAirInterface tutorials. Today we are going to talk about LTE frequency domain samples in OpenAirInterface. Our use case for this video is the FEM-BMS technology that it was extended by Javier Morgade. First, we are going to visualize the frequency domain samples without traffic. In this example, we use a frame that contains the cache or synchronization signals. For example, if you see subframe 0 and subframe 5 have easily, or we can recognize easily, the PSSS. Second, we observe the frequency domain samples without traffic, but for frames without cache or synchronization signals. So what happens if we introduce traffic into the system? In this example, we consider the frame that has the cache. That means that frame has the synchronization signals. We observe the constellation of those signals here in subframe 1 and subframe 6. Another subframes contains the samples of the PMCH. Let's analyze the system with traffic, but for frames that don't have the cache. So if you see here the constellations or the samples for all subframes belongs to the PMCH. Previously we saw the constellation of the subframes with and without the cache. And we observe that for traffic the system is using a modulation and coding scheme that belongs to 64 QAM. Now we are going to visualize only in phase samples in the frequency domain. So in this example we have subframe 0 and subframe 5. In subframe 0 and subframe 5 we can visualize SSS and PSS signals located on symbols 5 and 6. Also reference symbols in symbols 0, 4, 7 and 11. The PBCH symbols are located on symbols 7, 8, 9 and 10 of subframe 0. So now the question is, how could I get those frequency domain samples? How could I extract that information in OpenAirInterface and visualize them? So first you need to use the function called writeOutput. Second, define which entity do you need to extract samples. Is it the inode or the UE? Third, you need to look for the tx-data-f or rx-data-f array dependent of the entity you selected before. And finally, find the examples inside the OpenAirInterface code to guide you to extract this information. Then you need to create a script to visualize the signals. It could be Octave, GNU Plot, MATLAB, Scilab, or whatever software you feel comfortable. And finally, you can see an example in Octave of how to plot the constellation of one frame that has the cache or synchronization signals. So now it's time of questions. You can put them down below this video in YouTube. Remember, if you are new in this channel, please don't forget to hit the bell and enable notifications for future videos. I have news for you. The next video is gonna be related to the Magma installation. So be ready for the next video I will prepare for you.